Yes, sir.
चालत आहे माझे बाहेर डिस्कनेक्ट होतो लगेच.
Yeah, yes. Am I audible?
Yes, sir.
Good afternoon to one and all. So I want to first uh, know that how many of here are PhD students, just enrolled PhD students, or how many are faculties? Okay, no faculties, no faculties here other than you. It's fine. It's fine. It's fine. It's fine. But from your college, nobody is there other than you, right? Yeah. Okay. Okay. It's fine. So I hope everybody understand while we are going for PhD or we want to do PhD, we first design a question, which question we want to address, right? So in that direction, here, I suppose many of you as belongs to organic chemistry.
Yes, sir.
So if you say organic chemistry, in the organic chemistry, there are so many branches, right? Like in my PhD, what we did a chemical biology research. So we have taken some problem to solve. Likewise, while you are enrolling your PhD, you may have selected some problems to solve. So I want to know how many of you can just drop total means matches there. Your belongs to organic chemistry or physical chemistry or other branch of chemistry, so that I can cover as many as possible aspects of all the means related fields of chemistry. So first, please tell me how many of you here? You can just raise your hand. You know here the option is available. You can raise your hand. How many of you belongs to organic chemistry here? Okay, almost nine people are belong to organic chemistry. How many of you belongs to physical chemistry? Who already means raise their hand? Please keep your hand down now. Physical chemistry, three. Analytical, medicinal, or what we can say polymer, industrial. Okay, industrial one. So averagely, if we can say organic peoples are more here, some physical and some analytical peoples. Okay, so we will select such a problem which can cover all these three things. Okay, organic, physical, and analytical. So in organic chemistry, first question, whenever you select a problem, like most of the people who do research in like university, they target heterocyclic molecules, right? That heterocyclic molecules may have some properties only when they contains, like if the heterocyclic molecule contains thiol, the heteroatoms, then only they shows of biological activities. So you mainly targets heterocyclic molecules. To design that heterocyclic molecules, you have to first understand which problem you have to solve. Okay, in that direction, whenever you select problem for research, there are few questions you may first ask to yourself. Okay, the first question arises like which problem you want to solve. Okay, first question will be which problem you want to solve. Second question, how you are going to solve it. Third question will be, okay, you have problem, you know solution, but there is a very one important thing, that is resources. Which resources you have to solve that problem, to do that problem. Okay, then one is a resource. Third is, like fourth is planning for all these things, how you are going to plan these things. And fifth is deadlines. Sixth is what you are going to achieve from this. After doing all these steps, what you have achieved. Like first, we will go point by point, which problem you are going to solve. So the organic peoples, they can comment by in text also, like in their PhD, what they are means topic in short, like you are going to synthesize heterocyclic molecules and utilize their biological activities, or you are going to synthesize some organic molecules and you are going to monitor their fluorescence properties or their UV properties or physical properties. Or for some people, they will synthesize analytical molecule, they can be used for some biomarkers detection like cysteine or other biomarkers by using analytical techniques. So I want to know few, like one from organic, one from physical, and one from analytical. Anyone, they can unmute their mic and they can say which problem they are going to, means they have decided, or how they are going to, means what is their planning. Then we will, like if monotonously if I will comment and I will say, then that will not make sense. Okay, so I want three representative, from one organic, one from physical, one from okay, I got one person, Snehal madam, kinetic investigation. Okay, second person, anyone from organic. Don't hesitate, I am also the same. Okay, don't hesitate to talk. It will be very
Synthesis of novel molecule and knowing their biological properties.
knowing heterocyclic molecules, right?
Yes, sir. Heterocyclic molecule.
Okay. Anyone? Okay, heterogeneous catalysis, fine, good. Synthesis of heterocyclic molecule. Okay. Anyone from analytical? There are three people from analytical. Anyone can comment. No one? I hope they don't have problem. Okay, leave it. Now, I want to ask, Arun, can you unmute your mic?
Yes, sir.
So tell me, which heterocyclic molecule you are going to target?
1, 2, 3 triazole azole containing heterocyclic compounds.
Okay. Now everyone, from here, our literature survey starts. Okay. He has raised one question. Here he is going to synthesize a heterocyclic molecule. Now he has specified that heterocyclic molecule to triazole molecule, 1, 2, 3 triazole molecules. Okay. Please, Arun, don't unmute your mic until I say mute your mic. Okay. Now, first you have selected triazole molecule. Okay, 1, 2, 3 triazole molecule. Now,
Yes, sir.
how you are going to synthesize this molecule? Don't be like whatever organic chemistry you may have learned from our studies. You can give it any example.
Sir, can you clarify the question, please?
Like you said, you are going to synthesize triazole molecule, tetrazole molecule. Sorry, triazole or tetrazole.
I want to talk about purpose of selecting topic or method of preparing the molecule.
You have selected your title itself said bio active molecule, biologically active molecules, right? So that purpose was solved. Now you said like you are going to synthesize heterocyclic molecule which contains triazole, right?
Yes, sir.
And I am asking how you are going to synthesize that triazole molecule.
By taking the help of click chemistry, sir.
Click chemistry.
Yes.
Right? Okay. Now you raise another question. What is click chemistry? Like alkyne and azide, right?
Yes, sir.
Okay, alkyne and azide. This starts your you are going now in details in depths of literature. Okay, alkyne and azide.
Yes, sir.
Third, now these are the two starting materials. They may have to synthesize from some another starting material if they are not commercially available, right?
Yes, sir.
So you need a plan for this.
Yes, sir.
Right?
Yes, sir.
So you need a plan. Now suppose you got theoretically thought like alkyne you will synthesize, azide you will synthesize. You synthesize these molecules. But now which commercial molecules you will select for this synthesis?
For synthesis of azide, I will select, sir, aniline.
Okay. In short, like cheapest, right? Cheapest.
Yes, sir. Cheapest molecule.
Cheapest molecule you are going to synthesize because you may lack resources. That's why you are going to select the cheapest molecule. Now you have all the molecules. You have problem. You have aim that the molecule should show some biological activity. Then you have resources like you can synthesize that in your laboratory. You made a planning like you will synthesize it from alkyne azide by using some commercial or some synthetic methods.
Yes.
Now you will synthesize some deadlines, right? To do this research, you will going to synthesize this to this molecules up to this time. Then you are going to write your that work to publish in good journal, right?
Yes, sir.
And if you do all these things systematically, then you will achieve a good paper, good impactful paper, which we may published in international journal.
Yes, sir.
Okay. These are the things you think for first after designing your problem. Now you can mute your that.
Okay, thank you, sir.
Okay. Now we have one whole case study. Okay, to start for literature survey. I want to now ask one who said kinetic investigation. Snehal ma'am. Snehal ma'am, can you please?
Yes, sir.
I want to ask a specific question. Which kinetic investigation you are interested?
Simple organic compounds which are used in laboratory.
Okay. The kinetic investigation of simple organic molecules. Okay. Why you want to do that kinetic investigation for that simple organic molecules?
so that I can understand how they will behave in any reaction, in electrophilic reaction.
Okay. Then any molecule you have thought about which molecule like microacceptors you are going to select or some uh, electrophilic
But
despite of any reaction mechanism.
kinetics by electrophilic substitution reaction.
Electrophilic substitution reaction. Okay. These molecules you are going to synthesize in your laboratory or you are going to purchase it?
Starting material I have purchased.
Okay, and you are going to synthesize. Like after
Yes.
all the steps, as earlier discussed by Arun and us, all the trends will be similar, right?
Yes,
After
sir.
the synthesis. Then your next steps comes, Snell ma'am.
Yes, sir.
Up to synthesis, all are the same. Now you are going to use some
Yes, sir.
special techniques. Like which method you are going to use for kinetics? UV, fluorescence,
No, sir.
NMR.
Actually, hydrodynamic voltammetry.
Okay, hydrodynamic voltammetry. Okay, your problem is specified like hydrodynamic voltammetry.
Yes,
Okay,
sir.
ठीक है. हाँ. Like now we have another similarity here. You can mute your mic. Now we have another similarity. For these kinetic study also we need synthetic scheme, their synthesis and their utilization. Here madam using for kinetic purpose where he is using some specific instrument to monitor the kinetics. So okay, we have problem. Now if we start synthesis of this molecule, like suppose heterocyclic molecule, any heterocyclic molecule. For instance, in this demonstration, I will select some organic molecule, not a heterocyclic molecule, but I will start with the problem, how they started and how they search the molecules. Okay. So, can you see screen?
Yes, sir.
Everybody? Okay. See here, when now our first aim is to synthesize the molecule, like we want to synthesize the organic molecule. Okay, for that purpose, in many institutes in India, they have access to CAS SciFinder. This platform provides you a very much interesting data where you can put your molecule. You can see whether these molecules is already reported in the literature, or if it suppose if it is literature reported, how they have synthesized that molecule, and after synthesis for what purpose they have utilized this molecule, and where did they publish that molecule. All this data you can get in the same platform. So to start with, you have to first create your account. Here in this institute, Aizer Bhopal, we have our account, we have our login ID. So I have added that things. Now I just log in it. Once you log in it, can you see here this pop-up? Good afternoon, Dastagir. Anyone?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Yes, sir.
I am just making sure like I am on the different window. Okay. Everybody can see. I just want to make sure that. Okay. Whenever I ask, please anyone unmute and then just inform me whether you are that things are visible or not. See here, this window comprises like here a notification window. If you added some timelines or something to pop up, that they will show. Here you have 4 facilities, like you can design your project, you can label it. See here, I will first create a project. here I will write okay, any name you can add here. Now I have saved it. You can see here after saving this project one pop-ups here. Okay. Can you see this? This project one?
Yes, sir.
Okay. Now another feature is here. If any method you found okay interesting, you can means use that method. You can save that method. Like these are my previous data which I have saved. You will see these things here. So if you saved once, you need not need to see again and again. You can just go to saved and you can check it. And while searching this, if suppose in 1 day, 2 day, whatever search we have did, this will save in history. You can go there and you can rerun there. Okay. Now we came to our home page. Here is a one all option. Here you can add everything. See here, you can add substance name, caste number, patent number, PubMed ID, or DOI number, and you can go to search there. Then here you can just add substance and you can search. You can add here in formula. You can add formula and you can see their properties. Like here you can see experimental spectra. You can see over here whatever spectra people have reported. You can see here carbon, 13, nitrogen, fluorine, every spectra you can see here. Like they have used for some biological properties or not, you can see from this SciFinder. Similarly, you can see the properties like log P, log D, log C. You can see the reported densities of the molecule, and also the electric conductance you can see from this. Then another feature, if you don't want like direct substance to be searched, you can write a reaction. From A you want B, you can draw that and you can search. From here you can get references, and then similarly whatever molecule you are searching, whether that molecule is commercially available or not, you can see it from suppliers. So to start with, I will draw a molecule. You can see here one draw window is there. You have to click over here. You will go to cache draw. Okay, here all features are there, whatever very important to draw a molecule. Like here the substitution, brackets, charges, atoms. Here these are the basic atoms. From this chlorine you can you can add any halogen atom. Here you can add aromatic ring. Here you can, from here you can add multiple bond, single bond, or some denotions. So I have selected one paper from my lab which is recently published. Okay, we will synthesize this molecule, means we will draw this molecule. Okay, this organic molecule we will draw over here. This molecule contains benzene ring, one 5-member ring. For each you have to select from here. Okay, then this molecule is isatine, so it has carbonyl atom here. I can change. You can see here, this is a eraser button. You can select and you can delete it. Here I have directly added double bond. You can add single bond first, like go to the carbon then double bond, single bond. I will delete this first, then go to single bond. Again here, if I do it twice, it will end up with a double bond. If I do single times, it will give single bond. If I want to add here direct double bond, I will select here, I will add double bond. If I want triple bond, I will add direct triple bond here. Okay. Everybody understanding, or am I going fast?
Yes, sir.
Understanding, sir.
Yes, sir.
This speed is okay, right?
Yes, sir.
Okay.
Okay. Now, as I have shown here, this molecule contains here carbonyl group, here acetate group, and one is a acrylonitrile group. We will draw this molecule here. See here, I have this cursor is on double bond. So when I selected this hydrogen atoms, then also it is showing double bond. So whenever you want to select any new atom, make sure your cursor, this cursor is on right place. Okay. Now we need here one double bond. Okay, this structure is similar to that of this molecule. Okay, now we have drawn this molecule. Here you select OK. Now this came here, you just add search. See here, it is showing as drawn, there is no single molecule is reported. Okay, so something is different. See here, why it is showing it, nobody has reported this molecule, because here is like the molecule, this cursor is on suppliers. This molecule is not commercially available. But if I change to this to all and again search, see here, right? You can see this molecule, this type of similar molecules. Everybody can see this.
Yes, sir. Yes, sir.
Just what we made change here, initially we have selected suppliers, so this molecule is not commercially available. That's why the details of these molecules won't blinked here, right? Now we have selected all, whatever substrate is there, they all will pop up here. See here, these are different derivatives. It is not as same as we drawn, but it is showing similarity index. Okay, now we can select here substance. See here, the same will appears. If we select here reactions and search over here, nothing is showing. See, now if you want to suppose if we having some problem, it is not showing, so we can go to edit structure again. Here you can do edit. Okay. Now it is acrylonitrile, that is not, we are not getting very easily. So if you want to modify the search, you just delete this one. Now we can see whether this molecule is available or not. No, as such is not available. We will see in all. Okay, some similar structure is there. See here. This core is same as we have done, just instead of hydrogen, here is a ethyl group, right? This one. Here instead of hydrogen, it is ethyl group. So although we don't have exact molecule, but we have similar molecules. So we can see this, we can take this molecule, and now we can start a synthesis of this molecule. To start this molecule, there are two ways. Initially, people directly started synthesis, and then they will synthesize some starting material, then they will couple to them, then they will get their product. But another method is like retrosynthetic analysis, which is the hardcore synthetic peoples, like natural product synthesis peoples. They use the retrosynthetic analysis. Like they first will design this molecule, like this molecule they want to synthesize. Now they do some retrosynthetic analysis. For if you want to synthesize this molecule by using retrosynthetic approach, I want to know from like organic person, can you please comment any retrosynthetic approach, like how you are going to synthesize this molecule? This requires just a basic chemistry, nothing else, nothing your topic or else. This molecule. Anyone please.
Starting molecule will be aniline and
Okay. Any scheme. Okay.
aniline, acylation of aniline.
Which fragmentation first will happen? We will later see how you are going to synthesize this. If you want to fragment this molecule, from where you are going to synthesize fragment this molecule? See here, one option is
Carboxylic group, sir.
Amide.
which one? This one.
Amide linkage.
Okay. Anyone?
Hydroxy group is a first guiding functional group, sir.
Okay. Then you are saying from where?
Side
Sorry,
chain
OH.
eliminated.
From here you are going to cut this.
Hydroxyl group.
Hydroxy group, and then side chain is eliminated.
Okay. Means you are trying to say this hydroxyl group will be cleave, then this molecule will start synthesis.
Yes.
Okay, another one. Anyone? Anyone know Bailey-Silman reaction?
Yes, sir. Yes.
If I want to use that Bailey-Silman reaction, can it be possible to use Bailey-Silman reaction over here?
Sir, aromatic ring is there.
Yes.
How is it possible?
For Bailey-Silman reaction, what you require, right? One carbonyl group you will require, one Michael acceptor you will require, right?
Yes.
So, do you think here one carbonyl group is possible? Yes, it is possible. Okay.
Yes,
If you cleave this bond from here, can you see my cursor like this cursor?
Yes, sir. It is.
If you cleave from here, you will get a carbonyl group and one Michael acceptor, acrylonitrile, right? This is very simple molecule. If you want to synthesize natural products, if you are going to do retrosynthetic analysis, it will take too much time. Okay. So from last year, this SciFinder introduced one feature. Why I talked about this? Now you need to do all this retrosynthetic analysis by yourself. You just go this start retrosynthetic analysis, you just click over here. It will give you a different pathways for retrosynthetic analysis. Okay, now they have this is commercial. Okay, so they are asking for money. Okay, here, but you can get it. You can get the retrosynthetic analysis from here only. You just have to add these things, add detail, and you will get retrosynthetic analysis of any number of organic molecules. Like it may be your large chain natural product or any flavonoid or anything. You can just add over here. You just fulfill their requirements of paying money, and you can get retrosynthetic analysis. But this retrosynthetic plan will be based on the reported technologies. Whatever we plan, that may be just because of our knowledge. We may use like suppose some steps involve Bailey-Silman as stated here, because we know Bailey-Silman can be used, but sometimes what we learn from the book, they may not work in the practical. So for that purpose, the authentic retrosynthetic plan is also important. So you can get it done from here. Okay, I hope you people enjoyed this retrosynthetic feature of this CAS. Okay, this one feature we have done. Now there are two another features, like synthesize this molecule or get the reaction to synthesize this molecule, or substance details of this molecule. Okay, we will go to synthesize this molecule. See here, as mentioned, this is a electrophilic center, this is a Michael acceptor, and they have used Morita-Bailey-Silman reaction to synthesize this molecule. So from here you will get like this method can be used for synthesis of this molecule. If you want to go in detail, here they have provided the resources. You can click over there, that link that will take you to the journal. See here, they will give details of this molecule, from where in which journal this molecule is published. This is their DOI number, from which you can search the molecules. Okay, and also there is a feature. This is also added 2 years before to the SciFinder. Like from this platform only you can search these files. Earlier you have to go, means you have to select that reference, whatever they have reported, then go to respective journals portal, and by adding these details of that molecule or that published paper, you can get that paper. But now from the same platform you can access the paper. See here, if you can see here, this paper is published in here Tetrahedron Letters 2019, right? Now from the same platform they bring us 2019 Tetrahedron Letters. Now from here you can see that they have utilized this molecule for different application. They have synthesized this allene derivative by using the starting material. Okay, you have this paper. In paper there will be different sections. Now you need synthetic protocols. You just go down here, you can see here how they have synthesized these molecules. see here. This A1. This is a 1. Okay, this molecule is a 1. Here they have mentioned the isomerization reaction of MBH adduct 1 with butanediol and this malonitrile. Under micro condition, they have put this molecule. And from which condition they have synthesized, they may have cited over here. How they have synthesized 1. Okay. Or if they have not mentioned in the main text figures, sometimes they will mention in supplementary data. You can go to supplementary data, and from that supplementary data you can get the details of that molecule. Okay. Up to this, you understand the feature of this SciFinder? Hello?
Yes, sir.
Yes, sir.
If you have any doubt up to this, please feel free to ask. Anyone who has doubt up to this session?
No, sir.
Okay. So I hope everybody is enjoying. Now see,
Yes, sir.
we came over here. Now there in this picture, see here, this molecule of this synthesis of this molecule, you can see the different parameters, different features of this SciFinder. Here's publication name, organization, in which publication year they have published, in which language they have published, in which document they have published, like whether it is patent or journal paper, whether this molecule is commercially available or not, which type of reaction it is, or like in organic synthesis, you know that some reaction works at milligram scale, some reaction works at gram scale, some reaction works at kilogram scale. It may not be possible same reaction to work on all the scales. Some reactions they work on milligram gram, but they don't work on kilogram scale. Some reaction they may work on kilogram scale, but they may not work on milligram scale. There is very randomness of this reaction. So you have to screen all scales whether it is possible to do the synthesis on milligram, gram, and kilogram scale. And if you have specially achieved all these things, you can mention in the paper that you can synthesize these molecules on gram scale or milligram scale or kilogram scale. That will add impact to your work. See here, another. There is a mapping data. One feature. How many reactions are available for the synthesis of this same molecule? That will blink over here. Another, if you want to synthesize this molecule, which groups will hinder your reaction or may lead to the other side reactions of the your product? So this data is also available. You can see here non-participating functional groups. Like if you want to protect primary alcohol, secondary alcohol simultaneously, or if you want to protect primary alcohol in presence of secondary alcohol, or if you want to protect secondary alcohol in presence of primary alcohol, and that molecule has some other functional groups, whether and which groups will participate in this reaction, you can see from here. But to be specific, for this particular reaction, you can see here they are showing acyclic alkenes, amide, and nitriles. They will not interfere in this reaction. You can see here how many steps it requires. It requires only one step. So you can see here they are showing like in one step you can synthesize this molecule. Similarly, no yield available because these publishers they have not mentioned this yield, so that is not available. But if you take other molecules, they will be available here. I'm sorry. Now we have seen synthesize this. Now we will see gate reactions. See here. In synthesis, you have only one method, but in reactions, you have 4 methods. Same molecules you can synthesize by using this method. You can synthesize this molecule from sorry. Our target is this molecule, right? Now, in another paper, they have utilized same molecule for different applications. So, wherever this molecule is used or utilized in as a product, as a reactant, or any reagent, all will be shown over here. See here, this molecule they have utilized for this purpose. This molecule they have utilized for this reaction. Same molecule they have utilized for this disalter type reaction. Right? All the details you will get over here. Now, if suppose you want to know what data is already reported for this molecule, you can see over here. Get the reaction substrate details. See here. For this molecule, molecular weight is reported, boiling point is reported, density is reported, pK is also. I'm sorry. Anil. I'm sorry, you have any problem? Please ask.
इम्पॉर्टंट नंबर जास्त आहेत ना ते त्याला जास्त जीबीची पाहिजे 8 जीबीची कॅमेरा चालू करू टर्न ऑफ ऑन द गो चालायला लागला ना गप्पा चालायला लागला अर्धी स्पीड वर घेतो मोबाईल नाही टर्न ऑफ कर
Hello. Sir, is there any spectroscopic data is available on this?
Yeah. We can see over here. See here. They have reported molecular weight. They have reported boiling point. This is a predicted. Okay. If they have experimentally mentioned, then here instead of this predicted, there will be experimental data. Okay. Similarly, they have predicted this by using this CAS. Other names and identifiers. See here. Predictive properties. You can see here other properties like pH and their temperature and their bioconcentration factors. These are the chemical properties like log D, solubility, pK. Like these are all are the predicted properties. But if somebody reported that property, then you can see here. See here the density, molar volume, structure related like polar surface area, boiling point, enthalpy of vaporization, flash point, everything you can see over here. Okay, we will now modify the molecule. We have to go to edit drawing. Now instead of this nitrile, we will change it to ester. See here. We have added all. Now we will add over here substance. Here, This is also not possible over here. See, reactions, will select reactions. Zero as on no reported. Okay. Now we will change it because that is not reported. We will add here methyl group and let's see whether some similar molecules are available or not. All we will search. See here, right? In all, you have this molecule which is already reported as withdrawn. Now you just click over here, see here. How many reactions are available? 110. 24 ways are also possible to synthesize this molecule. There are 33 references which have synthesized this molecule. Yes, we will miss this. You will see. See here, these are the references. Synthesis of novel molecules where they have utilized this molecule. You can, from here also you can get all the details of this molecule. See here, there are 33 references. You will find all the references in same place. Like here, see, they have here, like they have synthesized that molecule and they have utilized this molecule for like this absorbance. This is UV properties, this is the fluorescence. So if you have selected some molecules, like ma'am said, like they want to do kinetic investigation, they can draw that molecule into the SciFinder, and just as we are searching, same you have to search it. If you search it, you will get a similar type of literature wherever that molecule is utilized. And after that, if you find okay, your what your molecule you are searching, nobody has reported that molecule for any application or similar application. According to that, you can take your decision whether you want to go with that molecule or you want to change some substitution, or you want to change the molecule, or you want to change the strategy. From this data you can select that. Okay, like
Okay, sir.
see here, this molecule is a substrate. Here, can you see here OH and Z group? Anyone? Hello?
Yes, sir.
And they have utilized this molecule with this anthracene group, and they have coupled that molecule, and you can see they have synthesized this two diverse molecule from this, and this molecule is showing different properties like in solution and powder form, and they have utilized this molecule for physiological like physical properties study. In this paper they may have, like, see here only they can say you can find for what purpose they have utilized this molecule. See, here is the second line. The spiro derivative synthesized in this work exhibit green fluorescence properties. The reaction occurred in metal-free, eco-friendly, clay-mediated condition. And final products have multiple structural features such as spiro, oxindole, fluorophoric, anthracene group, phenanthracene group, phenylene and perilene cores. Means all these things you can get from this abstract, and after that you can decide whether you want to go in detail of this paper to get more insight or not. That will be up to you then, right? Some See here, this 24 reference, deep eutectic solvent co-catalyzed synthesis of antimicrobial activity of Volta value silmanidec from izatin derivative, right? As Arun mentioned, he want like heterocyclic molecule which have some biological activity. This molecule shows antimicrobial activity, similar core. It contains heterocyclic molecule, which is izatin derivative, which has some properties like antimicrobial activity. They have synthesized this molecule, they have reported. And from this data also, you can see the synthesized molecule having some activity or not. Okay. This much means literature is available for your use, and you can get it from same platform. See here, now there are 33 papers, right, for this molecule. But now you don't want to see that 33 molecules. You want just recent applications. So you can add here from which year you want to see your that papers or not. Like I want to see just for 23 to 24. Apply. See. How much reference left now? 4. And from this data you can use any recent one. If you want only recent one, you can just screen this and you can select your strategy. These all are the filters, okay? All are the filters. Once you can add over, means you just search your molecule, you find so many literature is reported, you just add filter. See here, language is English. Some people report in Chinese, some people will report in German, some people will report in English, Japanese. All papers will be blink over here, pop up over here. But you know, we can understand only English, suppose. So you can just add filter over here, English. Then other reported methods in other language will not show. Okay. If you want to see, want to select a literature from some authors, like in synthesis, sometimes happens that if you synthesize some molecules and get published, that results are not reproducible. But some research groups, they have their unique selling point, means whatever they have reported, that reproduces. But so if you know some group like synthetic group, you know the scientist name, you just select that author and you apply that. Then what will happen? Others also eliminated out. See, this author has published only one paper. Now you don't need that 33 papers. You will just have one paper. You can just use this paper to search. Interesting, right?
Yes, sir.
See here, different count, different roles are there. Now, you want biological studies, you can select over here biological studies. Some want pharmacological activity, whether this molecule is reported for pharmacological, you can select this one. Somebody want that synthetic preparation, they can add over here. Means any properties, somebody wants this for drug use, you can add over here. And just apply these filters, other all information will not show up. Only your applied filters will show the details, right? You can, as like filter, you can exclude some things. You want to exclude, suppose you want to exclude these details, biological or these details, that will be excluded from the data. Okay. Whatever you want, like all the features are available over here. You just add that and you will get the details. See here, whatever filters we have used, we use English language, publication year, and this author, all will show. Now if we delete it one by one, See here, again you are having 33 results. So, and see now, earlier as explained, now we have these 33 results. I want to save this. I will go to this save option, save alert. Here I will add MBH adduct. You can save. And if you want to download, you can download from here. And now I want to add it to my project, which we have already created. I want to add this. So I have to select this, add to project. Any color I will select, that can be added. Now I have selected Abeda Inamdar. Now all the details will be shown in this. See here, menu, my projects, this project 1. See here. Right. Now next time you don't need to again draw the structure, again search. All the data you may have you saved here. Then this data, while you are writing your manuscript, you just go to this library, select whatever reference you have selected, and just use the data and write it your paper. Right? Anything else up to this? Anyone? Up to this is fine?
Yes, sir.
Yes, sir.
Okay. Now I will select one molecule which is having a like properties, fluorescence or UV. We will see how means you can search that molecule over here. I hope you are following me, right?
Yes, sir. Yes.
What is this molecule? Anybody knows? That is the structure. Anybody? Very common molecule.
Morphine.
Sorry?
Morphine.
No. This is a fluorescein molecule. Xanthine family. Okay. This molecule, its name itself suggests this molecule have fluorescence properties. Okay. Now we will search. Here you have to select all reactions first, or all, whatever you want. Go. See here. These are the different properties or substance details are available here. Now we will go for this core molecule. See here, this molecule is reported like use in 2000 around 300 research journals. See here, this much. See here, 23K references are available. Means this molecule is very widely used for different applications. And this much details are available. Now you want to synthesize this molecule, go over here. See here, how many 256 methods are available. Now there are different filters you can use. Initially it is 256, but what I want like 80 to 89% yield of the synthesized molecule. See here, only 4 results. Any one method I can use over here from this. Okay, I want above 90. There are 16 results over here. See here, there are like now here 16 results are there. You can rearrange them. You just change over here. You can select publication date, publication from oldest to newest, on the basis of yield, on the basis of step, on the basis of step in descending and ascending order. You can view this data in expanded or collapsed way. See here, it will just show reaction. If you use expanded, it will show the details. You can see it from scheme, document, transformation in by any way what you want. Here see how many participating groups, which I already mentioned. See here, this reaction works at milligram scale. 13 results are there who don't report, they don't report whether this reaction is work on milligram scale or gram scale or not. See here, reaction type, which reactions, there are 16. Which reagents, see here, there are different reagents are used in synthesis of this molecule. Acetic acid, sodium hydroxide, hydrochloric acid, methane sulfonic acid. You can use these techniques, like especially for who are working on heterocyclic molecule synthesis. Like Arun mentioned, he want to synthesize triazole molecule and he selected alkyne azide. You know, azide alkyne click reaction can be done by light, can be done by microwave, that can be done by mechanochromic by just grinding, or it can be done by some catalyst like acid, base. Okay, you can draw your molecule, place that means your command and see whatever method you are thinking. Like if you are thinking catalyst and you go to this reagent, see whatever you are thinking, suppose XYZ catalyst you are thinking, whether that reagent or catalyst is reported, you can see it from here. See here, these are only these are Lewis acid catalyst. These are Lewis acid catalyst used for the synthesis of this molecule. If you added that click reaction, same results will appear here, but catalyst will be different, reagent will be different. And from this you can select whether whatever you are thinking, it is useful or not. From this data you can think, select. Like some people want some reactions are happening in organic conditions. So they want in aqueous condition. You just draw that molecule and see whether this molecule is reported in aqueous condition or not. If that molecule is reported in aqueous condition, then there is no need to waste your effort in optimizing an aqueous reaction condition, because that is already reported in water. But somebody wants that reaction should be happen in DMS only. So you can see whether that reaction is reported in DMS or not. You will get this details from here. Okay, we will go to one property. Okay, we are here. Now see the substance details we want to see. Previously what we have seen, there they have only predicted data. Now here we will have the experimental data for these molecules. See here, you can get a molecular weight from for this molecule, melting point. See here, they have directly mentioned the experimental melting point. You can see here, they don't have calculated the boiling point because this molecule is solid, I know. So that's why they have predicted as boiling point, density, other names and identification. This molecule can be labeled in different names, like see here, benzoic acid, this is a common name, this is another common name, these are different names. Okay, yellow fluorescein, solvent yellow, all these are the different names. Anybody can report it in different any name, so you can see it different names for this molecule. Properties like see here, adsorption, desorption, metabolism, excretion, all these properties are used in ADME. There is drug distribution, metabolism, excretion process in this therapeutic applications. You can see here half-life, you can see over here somebody has reported. See here, these are all are the reported values. pK in different solvents. Some physical chemistry people, they want to understand the pK effect of pK in different solvents. You can see from here in which solvent they have reported, whether your target solvent is reported or not. You can see over here. Like that ma'am mentioned, she want to use for the kinetic investigation. You may have selected some solvent system to do the investigation. You can just draw that molecule and see whether the similar solvent system what you are supposed to use, whether reported or not. If reported, can you play around with different solvents? Okay, you can get the data from here. See, this is the diffusion coefficient, the optical properties, the structure related properties, whether X-ray, everything, like whatever people have reported, whatever properties people reported for that particular molecule, you can get it over here. Like experimental spectra. You can see the H1 NMR, like water D2 or DMSO, D6, all you can see over here. And which papers and where this actual data for this molecule is reported. You can click over here, this organic molecule, Indian Journal of Organic Molecule. We will come here. You just go to their source and you will get the exact data, experimental spectra of that molecule. Okay. Some are regulatory informations will be also there. Some hazard statements, like suppose some chemicals are fuming, how they will affect your health, how to use, like MSDS on every commercially available chemicals you are getting MSDS, right? Same way you will get the details over here. There are some additional details, like which category this molecule comes, small molecule, either peptide or protein, right? You will get all the details over here. Now everything is available with you, right? By looking all the data, you have all the literature reported values, yield, and properties. Now you can you can select which problem you want to solve, because all the details you have. Then another feature. One important feature is also there. Before that, I want to know, everybody is okay or bored?
Okay, sir.
Okay, sir.
Okay, na? Please let me know if you are tired or feeling like it's okay, it's too time, then let me know. I will stop. See here, now up to this, what we have done, we have drawn a structure. We have manually drawn a structure. But there are some molecules who reported in the literature has some CAS number. So suppose here I will add some molecule like cyclic di-GMP. Can you see this molecule? Can you see this molecule?
Yes, sir.
It
Yes,
is
sir.
large molecule, right?
Yes.
If you want to draw this molecule in ChemDraw, it will take time, right?
Yes.
And you want to do some modification like over this carbonyl group or amine group or NH group or any this alcohol group or this phosphate group, anywhere you want to modify this molecule. So you need like to draw this molecule first, then add the substitution whether this reported or not. You can get it done very quickly. See here, this molecule has some Cas number. See here, this is a Cas number, right? Just copy this Cas number, go to your scheme. Here you have Cas inquiry number, you just paste over here. Okay, and just select here. See, right? Just fraction of second you got all whole molecule, right? Is it visible?
Yes,
Sir,
sir.
again show the CAS number.
Huh?
Sir, please again show the CAS number.
See here, this molecule I have shown, right?
Yes.
Here is a Cas number.
Yes, sir.
Any molecule which is commercially available or some molecules which are not commercially available but deposited in this library, they have some their Cas numbers.
Okay, sir.
You can just copy this Cas number.
Yes.
Right?
Yes, sir.
You just paste over here. You just select this T. Right? Within just fraction of second. Okay, now we will draw the same molecule, that fluorescein molecule we have manually drawn there. I will add here. Right? You can get it done in fraction of seconds. Now you just need some derivatization anywhere you want to derivatize this molecule, aromatic ring, alcohol or carbonyl, whatever you want. It is just in fraction of second. There are another features like smiles and these are also available on websites. Like if you go to that cyclic di-GMP, See here, this is a smiles. You can copy this also. You can add over here. See, the cyclic diGMP molecule will be there. Same way. Whatever you should like, okay, you can select that. Like this also, if you add to the cache. Right? They just in fraction of seconds, all the details you have. I think I have covered all the features of this SciFinder. If you have any questions, feel free to ask.
Hello, sir.
Yes, sir.
बोलिए. Okay. Where is that?
OSM.
थांबायचं मग थोडा वेळ
आपली UM वेबसाईट ना, TYचे पेपर चेकिंग.
This molecule is reported in OH form. Pune, already from same, I think, Journal of Pure and Applied Chemistry, Indian, an international journal, Goswale. Okay. Anyone has any other molecule? It is like, but it is derivatized. Okay. Here, whatever you ask the query, that is OME, right? It is of OH. So here, these are the different. This is also reported for OME. Also, that is reported different position, but different applications. These are different references. Haven't received. I haven't received yet. Siraj sir, am I audible? I haven't received. Yeah. Not reported. It is not reported. Not at all. Their substructure also not reported. Anything else? Anybody has any questions up in this session? Utilize this opportunity whoever want to do some organic synthesis. If they have some plan, utilize this opportunity. Just send it to sir. I will find you for you. Anyone who wants like do some synthetic molecules, just feel free. Send it to sir. Anyone has other queries like you don't like understand or somebody has some query like they missed something? Yeah, Arun Gawande.
Sir, how one can get the access to SciFinder?
Oh, that is institutional. Like institute has to pay some money to this SciFinder, then only you will get the access. And institute provides this access to the student. Like in ISER,
It means personally we cannot.
yeah, we can't do that.
Okay.
If you want to do some SciFind, please find some friends who are doing like in ISER Pune, Pune University, NCL or IIT Bombay, anywhere else. They will SciFind for you.
Okay, understood, sir.
But individually you can't do that. Anything? All the things. Have you enjoyed? Okay, give it some feedback. Whether you enjoyed this session or not.
Yes, sir. It is something very new for me personally.
If somebody has like other like questions, how to start the research problem and whatever I have asked anything like related to that? Thank you. I think everyone is fine and satisfied with my explanation. Okay. Sir, please. Can you please turn on your videos all? Please, all who are yet connected. I did that. Okay. I think nobody. Actually, I am from Maharashtra. Okay. And I did my master's from Dr. Babasaheb Ambedkar University, Aurangabad. I just want to make sure some familiar faces